In an extensive series of PowerPoints, we developed a class that will take a bunch of text, drop it into a text area, stick that text area into a scroll pane, and as you see here, we'll manage several of those, all of which are supposed to be at the bottom of the screen. As the user resizes the screen, there may not be enough room, and they're automatically stacked as needed, as you see over here. The complete program you saw earlier in here. I split it up into its two component parts. This is the one that we're going to use in our application, and this will be the program that will drive it. I will recap those PowerPoints so you can find them as needed. But before I do that, I'm going to make one little generalization in how we provide the text to SWA to put in the text area. You may recall this method. Its job was to take the text that would eventually appear in the text area and send back the text area. It also, as part of that process, had to find out the maximum width of a line, both in pixels and characters, as well as counting the rows. In order to take that string out, we have to pull out the lines. And I did it with some standard character processing code that looked something like this. At the end of it, we had a line here. This was the line that we would analyze to find out how many pixels it was and what its width in character, or how long it is as there. So to do that, we ended up with this processing here. This is the routine provided by AWT Toolcat to take a line. This is a context area which represents where we're going to put it, and it will tell us how many pixels it will be when we actually put it on the display. And we just take the maximum of it, and we also increment the number of rows. Not shown here, we also take the length of L in characters and process that as well to get the maximum line. So to make a fairly short story still short, we took this method that you've learned to know and love and made a new version that takes an array, and I just simply cut and pasted and made the obvious changes, and I tested over here. And then I made another version, again by cutting and pasting and making the obvious changes to use an iterator, and tested over here. So here's that recap that I promised you. Here are the PowerPoint files, and in fact for each of these there's a Java program of the same name and an ASCII file of the same name, sometimes more than one Java program with slight variations in the name that correspond. This one, being the first, introduces GUI programming in these two systems. By the way, this was the first one, and a lot of Java Swing is built on top of this. I've taught a lot of this in the Graphical User Interface course, CS412. For 5 years, the second 5 years I was teaching this, which corresponds to the first 5 years of this century, we taught Graphical User Interface in Java with these systems. Before that, we used Visual C++ and C programming and Windows programming. I introduce the concepts of responding to a button, getting buttons and other controls on the screen, and reading a text box. And this part just talks a little bit more about getting a control to appear properly on the screen where we want it to appear. Now we get into the raison d'etre of this series and my efforts: multi-line text boxes. In AWT we have this option here, which by the way includes built-in scrolling when the text in the text area doesn't fit in the size. So if we make a text area, say 5 lines, and you throw 79 lines in there, automatically throws up scroll bars and automatically scrolls. In the case of Java Swing, this does not do any scrolling. We actually have to put this inside of a JScroll pane. We also have to find out the size of the strings that we're putting into the text area. And by size, I mean how big are they when they display. And in order to do that, we actually have to go through the GUI system because we don't know how many dots per inch are on that particular monitor and so forth. And I talk about this important AWT method. In the case of this one, it doesn't scroll, as I mentioned before, so we have to put it inside here. So here we talk about getting the text area that I've properly sized beforehand and putting it where it belongs in the center of the bottom of our screen. Here, by the way, we're still dealing with just a single text area. We're not trying to deal with multiple ones. But maybe we have more than one text box that we need to put someplace. And we actually have inside of the SWA class a set of arrays to keep track of the height and width of each of them. And of course, an array of pointers to keep track of the text or JText area or JScroll pane itself. Also, in this particular PowerPoint and program, I introduced the idea of designated a spot along this bottom place for each text box. They don't all have to be centered around the width. And that's just another array where I record the desired position and whether or not the programmer wants the thing centered or adjusted relative to the left-hand side or the right-hand side. And here we actually finish the SWA class support conflict detection. So for example, this item here doesn't conflict with any of the other items. We can place it at the desired place a few pixels from the right of the window, but we also can detect a conflict like this and determine that this guy actually has to end up here. So that takes us to this PowerPoint here, which you just have observed. I'm now going to take the SWA class that seems to work fine here and drop it into Participatory Democracy Backend's front end, which I call AppFiat app. You can go ahead and drop it into your application as well. However, I'm going to do one more thing here. It is possible that this may actually end up being used in a real course. So what can we do in terms of expanding upon this? First of all, the most obvious thing to do, and should be a relatively straightforward modification, is I've assumed that the programmer using this class wants all of the text boxes at least if there's room, to end up oriented on the bottom border or bottom edge of the containing window. You probably could very easily modify this so that we could have a set of text boxes along the right edge, the top, and the left-hand side. Now, one thing that I had to do was I wanted those text boxes to appear. There were other text boxes that appeared there, having nothing to do with this, buttons and text boxes and stuff like that for the budget itself. So we ignored those. We just dropped these in, ignoring anything else that would be here. We could try and avoid that. We could actually, there's a get components command, and you could find out what's here and try to avoid conflicts not only with each individual text box, but what was already on the screen. And if you are dropping things on either of these, you could try and avoid conflicts with each of those. And I just happen, and I guess also related to that is I just happen to, if this came too small and therefore this just ended up becoming on top of that, I put this over here. I didn't try to find another location like over here for it or something of that sort. So we could, if you will, play a kind of a game of Tetris here, and as the window shrinks, explore different ways of dropping the things that overlap so they don't overlap. So perhaps you'll end up modifying and expanding on these programs, and you're welcome to do so. I'm going to put them out as open source and as a teaching aid, and you're welcome to do whatever you care to them for your application or edification or for the better good of the community.